Let's dive right into this explainer. You know, we walk on the ground every single day, but we rarely stop to think about the fact that the earth beneath our feet is actually a living, aging entity with a fascinating lifespan of its own. It's literally born, goes through a pretty rebellious youth, settles into a deep maturity, and eventually reaches a slow, meandering old age. Our roadmap for tracking the planet's dramatic geological life cycle covers 6 stages. We'll start with the recipe for soil, move into the biological engine, look at the geological lifespan, and then trace the eras of the reckless youth stage, the deep mature stage, and finally, the slow old age. Starting with Section 1, the recipe for soil. To really understand massive landscapes, we first need to look at the birth and the flesh of the earth at a microscopic level. So, pedogenesis, which is just the scientific term for soil formation, starts with a foundation. You absolutely cannot have soil without a weathering mantle. That's essentially the depth of the weathered material resting right there on the Earth's surface. This weathered rock and transported deposit acts as the basic raw input. It is the blank canvas for literally everything that follows. Now think about how the birth of a sponge-like, mature soil is sequenced. It definitely doesn't happen overnight. It starts with that bare, weathered material. Then it gets colonized by bacteria and simpler plant bodies like mosses and lichens. As those minor organisms take shelter and eventually die, their remains help build up a layer of humus. Next come the minor grasses and ferns, and eventually birds in the wind bring in seeds that allow bushes and deep-rooted trees to take hold. Burrowing animals come in, mix it all up, and make the material porous until it finally becomes this beautifully complex, mature mixture of minerals and organic products that can hold water and air. But here's the thing. This entire sequence is governed by 5 specific factors acting in total harmony. You have passive controls, like the original parent material and the topography of the land itself. But then you have active factors, primarily climate, which completely shifts the recipe. Climate is a powerhouse. In dry climates where evaporation outpaces rainfall, capillary action pulls groundwater up to the surface, leaving behind crusty salt deposits known as hardpans. In wetter, tropical, or intermediate zones, the climate might cause desilication, which is the removal of silica, or it might create calcium carbonate nodules known as canker. Add in biological activity and, of course, the magic ingredient of time, and boom, you have your soil. Moving right along to Section 2, the biological engine, because life itself is the active engine pumping vital nutrients into this newly born Earth. You see, soil isn't just some passive sponge, it's a bustling biological factory. Take nitrogen fixation, for example. Bacteria and other soil organisms literally pull gaseous nitrogen right out of the thin air and convert it into a chemical form that plants can actually use. A really cool example of this is rhizobium. It's a type of bacteria that lives directly inside the root nodules of leguminous plants. It captures nitrogen to feed its host plant, which in turn adds rich organic matter and moisture retention back into the earth. It's just a brilliant self-sustaining loop. All right, so having established how soil forms the literal flesh of the earth, we have to step back and ask a much bigger question. How do the massive bones beneath, the actual landforms, shift, degrade, and transform over immense stretches of time? How in the world does a towering mountain eventually become a perfectly flat plain? That brings us to Section 3, the geological lifespan. Because just like a human life, a landmass passes through distinct developmental stages: youth, mature, and old age, driven constantly by the relentless flow of water. The journey of a landscape always starts with simple water erosion. It kicks off with overland flow causing sheet erosion. Because the land is naturally irregular, the friction of this flowing water concentrates into small, narrow paths called rills. Given enough time, and these minor rills deepen and widen into long gullies. Eventually, those gullies lengthen, they unite, and they give birth to a massive, complex network of valleys. This is the exact mechanism that ages the Earth. Which leads to Section 4, the reckless youth stage. In its early days, the landscape goes through a pretty reckless youth characterized by aggressive downward cutting and incredibly rapid changes. During this super energetic youth stage, aggressive downcutting absolutely dominates the landscape. The streams are few and they really aren't well integrated yet. They flow over the original steep slopes, carving out shallow V-shaped valleys. Because the rivers are cutting downwards so aggressively, there are basically no floodplains at all. Between these streams, you'll find broad, flat divides riddled with marshes and swamps. And most iconically, wherever local hard rock bodies are exposed to this aggressive downward cutting, you get dramatic waterfalls and intense rapids. And the specific type of rock these youthful rivers cut through dictates the kinds of dramatic scars left behind. If a useful stream is cutting through hard rock, it carves a gorge, a deep valley with incredibly steep, almost straight sides. But if it cuts through horizontal bedded sedimentary rocks, it forms a canyon that's characterized by those iconic, steep, step-like side slopes, much like the famous Grand Canyon. The sheer power of this youthful stage is just incredible. I mean, over rocky beds, streams use the abrasion of rock fragments to literally carve circular depressions called potholes. Imagine a tiny pebble caught in a fast current, spinning endlessly in a pothole until the hole grows. When this happens at the foot of a huge waterfall, the sheer impact of the falling water, combined with those rotating boulders, drills massive, deep holes straight into the solid rock. We call these plunge pools. Next up is Section 5, the deep, mature stage. Eventually, all that reckless downward cutting slows down, and a land settles into its deep, grounded, mature stage. So in this stage, the landscape actually matures by completely changing its behavior. The streams become plentiful and highly integrated. While the valleys are still V-shaped, they are now much, much deeper. The aggressive downward cutting gives way to lateral erosion, meaning the rivers start eroding their banks sideways. This creates wider floodplains where streams begin to lazily meander and curve. The broad divides and swamps from its youth, they disappear entirely, replaced by sharp stream divides. And those dramatic waterfalls and rapids are completely smoothed out. Now, normally, we think of meandering rivers as something that only happens on soft, flat floodplains, right? But the active lateral erosion of a mature landscape is so persistent that we sometimes see very deep, wide meanders cut directly into hard rock on gentle slopes. These are known as incised or entrenched meanders. They are a great reminder that even solid stone can't resist the steady, mature carving of a laterally eroding river over time. As these mature rivers occasionally shift back to vertical erosion, they cut down into their own depositional floodplains. When they do this, they leave behind stepped landforms called river terraces. If these terraces sit at the exact same elevation on either side of the river, they're called paired terraces. You can think of river terraces almost like the wrinkles or the history lines of a maturing valley, showing us exactly where the riverbed used to sit in its younger days. And finally, we arrive at Section 6, the slow old age. This is where the landscape loses its steepness completely, relaxing into a slow, meandering old age. In old age, the fiery energy of youth and that deep carving of maturity, they're completely gone. The landscape is now characterized by just a few smaller tributaries flowing over incredibly gentle gradients. The streams meander freely and lazily over vast, sweeping floodplains. This is where you start seeing features like natural levees and disconnected oxbow lakes. The sharp divides of maturity have worn away, returning to broad, flat divides dotted with lakes and marshes. And most importantly, the entire landscape has been worn down until it sits right at or just slightly above sea level. Ultimately, centuries upon centuries of continuous stream erosion flatten the land almost entirely. What was once a rugged mountainous youth is now just a lowland of incredibly faint relief. We call this type of landform a peneplain, which literally translates to an almost plain. The only hint of its former towering glory are a few stubborn, low-resistant rock remnants standing out here and there. Geologists call those mononocks, mountains reduced to plains. This one singular, powerful truth really highlights the unfathomable scale of geological time. The soil forms, the biology fuels it, and the relentless water carves it, ultimately smoothing the jagged edges of the Earth into flat, serene lowlands. The Earth's lifespan is constantly unfolding all around us, so next time you step outside, just take a look at the horizon. Whether you're looking at a deep, straight gorge, a set of stepped river terraces, or a flat, meandering floodplain, ask yourself, what chapter of the Earth's grand biography are you currently living on? Thanks for joining me for this explainer, and keep looking closely at the ground beneath your feet.